Ah, thank you so much. I have to say that's the coolest intro I have ever seen. So kudos to whoever did that. Welcome. Today we are going to talk about Qwik framework. You might be asking why another framework in this world, and I will answer all these questions. But first, let's do a bit of an introduction. So hi, I am Miško. I'm the CTO at Builder. You might have heard of these things called Angular, AngularJS, Karma, and Clean Code Talks. And I might have had something to do with that. So that's me. A little bit of Builder.io, who I work for. So we are a visual development platform. And when I first started, I had no idea what that is either. So I'm going to give you like 30 seconds of what it is because it ties into why we're building Qwik. So imagine you have a website like on the left, and the marketing department says, you know what, we have to change it to the website on the right. And so you probably have to do something along these lines. You have to change your code and be like, yeah, changed. The problem with this approach is that it never ends. Marketing will always ask for changes, 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 and changes. And so you're probably like, oh, I know what I'm going to do. I'm going to integrate a CMS system. So you might have to do something like along these lines. And you think you won, except you haven't, because the marketing is going to be like, but we want the percentage to be bold. We want 2 sales or something of that sort. And so this doesn't particularly work either. And so you can install Builder. You can cut the code out. And you can do this important thing on the bottom, which is the register component. And you can paste it into our editor. And then the marketing people can do everything by themselves without bothering you. So how does Qwik come into this? Well, most of our customers are e-commerce customers, and for them, speed matters. And Qwik is a new kind of framework which is focused on speed. Now, what kind of speed are we talking about? There's a lot of different kinds of speeds, and specifically the thing we care about is the startup performance, right? There is how long it takes when I click to update something, and that's important, and we think we're performant. But I would say that all frameworks are good enough at this particular category. Instead, the category we're focusing on is how long does it take from the point I visit a website until I can interact with the website on maybe a slow device or slow network or something of that lines. So Qwik is really all about the time to interactive performance. Now, you might say, hey, there's already a bunch of frameworks that claim to be quick at this thing. Why do we have a need to have another one? And so, I'd like to take next 45 minutes or so, and I'm going to talk to you about how Qwik is different and hopefully convince you that it is something totally unique, and it's not like the other frameworks that we have today, and it solves a set of problems that the other frameworks fundamentally cannot solve. So we mentioned that we care about performance, and this one we care about the most is the make the fastest possible time to interactive, right? That's the metric. And why do we care about it? Well, turns out Google cares about it in the sense that the SEO ranking depends on your performance of the website. If you have a slow website, Google will actually rank it lower. And so if you're an e-commerce website, you probably care about this a lot. And of course, there's a lot of evidence that says Qwik websites actually do better conversions, better performance, and so on and so forth. And so speed is money is really what it comes down to, right? And so you would think that if you go on the internet and look at all the different e-commerce websites, you would have some really amazing time to interactive. So this is Google PageSpeed, and basically what it tells you is that pretty much all of internet is in the red, and some companies that can actually spend the money, like Amazon, can get themselves in the yellow. But pretty much nobody is in the green because it's super, super hard to get in the green. And what I find super interesting is that when your website doesn't perform well, it's a natural tendency for people to just blame the developer. Oh, clearly the developer messed up, and only if you got better developers that cared more, etc., you could do a lot better. The thing is, if there would be some examples of websites that are actually performant, I could buy that argument. But actually, when you look at the web, you'll notice that all the websites are just non-performant. And so getting a green website is kind of like a unicorn. It doesn't actually exist. Now, people have green websites as a demo website, but I'm talking about a real website that actually handles traffic, that has analytics, and so on and so forth. And I'm going to try to convince you that the problem is the amount of JavaScript we send to the browser. So if you look at different websites and how much JavaScript over time goes in here, what you see is that our website, our JavaScript bundles are getting bigger. And it's tempting to just say like, oh, it's the same website we had 10 years ago. We're just getting worse at this. But I'm going to argue that's not the case. The websites of today are a lot more powerful than websites of 10 years ago. They're a lot more interactive. They have more capabilities. They have better insights for the companies into like what the user is doing. So really, all this JavaScript code is not just random bloat. It's actually features and behavior that is actually integral to what the website is. But this JavaScript is actually the problem because, well, browsers have this weird quirk that they're single-threaded, right? And so the fact that in recent years we get these multi-CPU processors are actually not helping here. And so this isn't a problem that's just going to go away if you just wait. We have to actually actively do something about it. Now, the thing I want to show you is we have this tool called Performance Insights, where you can type in random websites. So in this particular case, I'm going to show you Priceline.com. And what it shows you is that when you run it, it feeds it to Google PageSpeed. And Google PageSpeed returns a score for this particular website. And it said it's 36. And 36 is kind of normal for an e-commerce website. So in that sense, it's not special. And what we can do with this website is we can optimize the images and then run it again through Google PageSpeed. And in this particular case, when we optimize the images, we get the same exact score. What it means is that Priceline has done a fabulous job of optimizing their images. There is not much we can do to improve the situation. Same thing for the CSS. Is we try to optimize it, we realize we get the same exact score, which means that they've already done a fabulous job. Which means as an industry, we are pretty good at optimizing images. We're good at optimizing CSS. Notice what happens when we optimize JavaScript. Now, this is a bit of a simulation, but notice what happens. We go from 36 to 96, right? Now, this is kind of, I said, optimization, kind of a trick, because really what we're doing is we're just disabling JavaScript. We're saying, look, this exact website, if just it didn't have JavaScript, this is how fast would it be, right? And so our job is to then figure out how do we make a website which doesn't require so much JavaScript, and this is what we're going to talk about in this talk. Now, this is just top 50 e-commerce websites all across, and it's the same story, right? Optimizing images, in some websites helps a little bit. Optimizing CSS helps a little bit. But gee, if we could only fix the JavaScript problem, the performance improvement we would have would be absolutely huge. So now we're talking about JavaScript. Why is this a problem? So in a single word, the problem is something we called hydration. And all existing frameworks have this particular, for lack of a better word, problem. And this problem goes like this. You're a website, and because you want to have fast visual output for the user, you pre-render the code on a server. So you have your server-side rendering or server-side generation, doesn't matter, right? You return, basically this thing allows you to return HTML to the browser. The HTML immediately shows up, and the browser needs to do something because the page isn't interactive, right? HTML is static. And so there's a piece of Bootstrap code in your website that says, great, I need to make the page interactive. And so how do I do that? Well, this is kind of the problem. This big fat arrow represents your application, right? In order for the website to become interactive, your application has to be downloaded to the client, but not just downloaded, executed on the client. And then download and execution then allows the framework to build up its state, run the renderer, and the renderer can figure out the delta between what is inside of the HTML and what is what the application says it should be. Hopefully the delta is 0. But it also gives it the listeners. And at this point, it attaches the listeners to the DOM. And at this point, we have an interactive website, right? However, all of this code right here directly impacts time to interactive, right? This is why our websites are slow, right here. All of this JavaScript that has to get downloaded and executed before the page can become interactive. And so what Qwik does is it says, right, we're also going to start with SSR, and we're going to, of course, have a piece of Bootstrap. But in our case, the Bootstrap is very tiny. It's about 1 kilobyte. And on a desktop machine, it takes about 1 millisecond to execute. Maybe on a phone, it will take 10 milliseconds to execute. The point is super, super cheap. But notice what happens. We completely bypass everything and we go straight to interactive. In other words, we can make an application interactive with 1 kilobyte and about 1 millisecond of execution time. And then it's only when you interact with the application do we start downloading the actual code. Now, I want to point out that the arrow over here is a lot skinnier than the arrow over here. And that's because this fat arrow represents your whole application. This skinny arrow basically says that we know how to download just the JavaScript that you require to process that interaction and nothing else. And so what you actually end up with is a world where as you interact with the application, more and more JavaScript gets downloaded, and more of the application basically comes to the client. So it's very interactive. Now let me show you what the end result of this is. So this is our homepage. This was built using both React Next.js and using Qwik. And when it's colorful, it basically means JavaScript is running. And when it turns gray, that means that all of the JavaScript has finished executing. Notice the difference in performance. We're talking about 1.9 seconds versus 8.1 seconds on a simulated mobile device. That's just a huge difference in performance that you could get if you can do this correct. Before I jump into demos, I want to take a little detour and talk about Partytown, and I'm going to show you some cool demos that are actually going to demonstrate everything we've been talking about. So what is Partytown? Well, we're really focusing on JavaScript. We're focusing on the problem that, hey, there's just too much JavaScript in your application, and by removing the JavaScript, we can solve the problem, right? Turns out there are two kinds of JavaScript on your website, right? There is your first-party code that you wrote using some kind of a framework, either React, Angular, Vue, Svelte, whatever you chose. And there is third-party code that you kind of need for your application. And third-party code, it would be things like Google Analytics, Facebook Pixel, HubSpot, Intercom, and so on and so forth. Typical website has as many as 20 plus third-party scripts on their page, right? And what all of these third-party scripts do is that they eagerly download and initialize. And because JavaScript is single-threaded, it creates congestion, right? That the amount of code that you require for your application is basically drowned out by the third-party scripts. And so in real world, in production, even if you manage to somehow build a site that gets 100 out of 100 for the basic thing, the moment you start adding third-party scripts, you will destroy your performance. And of course, if you go to the marketing people and say, hey, we don't need these things, you're going to be shut down saying, well, actually we do. We need to know who's using it, how's using it, and so on and so forth, right? And so what Partytown does is it can do this magical trick that it moves all the third-party scripts into the web worker and execute it on a separate CPU core so that your main thread is left for the application for itself. So anyways, this is a separate project that we're doing, so this is just kind of a, there's really no reason why you shouldn't integrate Partytown to your website, so go check it out. Anyways, enough of me talking. Let's show some demos. And how's the font? Is that good? Okay, and I'm going to make this font even bigger. Okay, so let's start with the simplest possible hello world. And I think an important part when you get started is to talk about what the developer experience is. If you come from the world of React, Qwik is very, very similar. And this is no accident. This is not accidental. We specifically looked at it and say, how can we make the DX most familiar to most people, right? And so if you look at what a Hello World component would look like, this is very, very similar to what you would see in other frameworks. The only thing that's different is this component. And there's this magical $ in there. And I'm going to explain the $ in a second. But in here, you just return your JSX. And if you look at the resulting HTML, you'll see that the HTML that came from the server just contains all the parts. That in itself is not interesting. What is interesting is that if you look at the network tab, you will see that the network tab is empty. Specifically, I'm filtering for JavaScript code. And so no JavaScript is downloaded, right? And so what Qwik is a framework that doesn't concern itself with just rendering, but really concerns itself with the whole pipeline, right? It's not about just like, hey, I render, I'm done. It's also about like, how do I bundle this? How do I figure out what code to send to the client? How do I execute the code? How do I bootstrap the code? And all of these things cohesively together are put together. And in this particular case, Qwik basically said, no JavaScript is needed and nothing got sent over here. So that in itself is not interesting. You know, any framework can basically not send JavaScript. So let's do a little more complicated example. So here we have a counter. Again, notice no JavaScript, but I can interact with the counter. If I click on it, the count goes up. And if you notice, when I did that, code got downloaded. Let me refresh this again. Notice what's happening in the network tab. Me clicking on a count downloads the code. Now, what kind of code? How does the system know to download the code, I guess, would be the question you should be asking. And so let's look into that. So let's look at the click. And what you'll see, and I'll refresh this one more time. What you see here is that you have a button. And a button has an attribute on it that says, what should happen? Where should I get the code if I interact with this button, right? So in this particular case, we're saying if a click happens, this is where you go and download the URL. The URL is very long because this is in dev mode, and so we're not making it short. And also, this is the symbol that the URL exports that you have to execute. And then I will explain this magical 0 on the end in a second. And this basically is the counter. So let's look at the source code. What does this look like? Again, something that should be pretty straightforward. We declare a counter. We declare a component, $, and I'll explain $, in a second. We're going to declare our state, which is very similar to use state. So we have a store. We're saying we have a count of 0, and we will print the count. And we have a onClick, again, $. And we say, well, if you click on this, you should increment the count. Now, what's up with all the $signs? Every time you see a $sign in the source code, it's a hint both to the optimizer, which is the Qwik, and also to the human. What it says is that, hey, over here is a asynchronous boundary. The code that is behind the $sign will be lazy loaded. So just keep that in mind as a developer, right? So whenever you see a $sign, that's a potential place where a lazy loaded code can exist, and also a potential place where the system can tree shake a piece of code saying like, actually, I don't need it. You know, for whatever reason, I decided that I don't need the click, I don't need it. So if you look at the network tab, when we first click on the button, the first piece of code that gets downloaded is this bit over right here, which is basically the onClick, right? So the onClick says take store count plus plus. But there is a little bit more stuff in there, and so I want to kind of explain what actually is happening, right? So what the optimizer does is it says, great, I see a $sign over here, so I'm going to take this piece of code and I'm going to delete it, and I'm going to replace it with a constant. And I will basically pull this constant out into a separate file that I'm going to export, right? So this thing matches this piece of code over here. But notice what's happening. The store was a closure which captured the store, right? And so now the system is like, hey, I don't know what store is. In other words, closures are the things that make writing code convenient, but it's also the thing that makes lazy loading code essentially impossible. And so how do we solve this? So what we do is, we do a little bit of magic here, where we insert this use lexical scope, and this lexical scope basically say, go and restore the store property or the store state or the store object before I use it so that I can do store count plus plus on us, right? And so every time, let me just, that's the wrong button, Okay, every time you see a $sign, basically the optimizer breaks your code up, puts it in the separate files, and then glues it together. So let's look at the application again. One of the things you will see is that, again, our button has this, but also we have this script tag right here that contains the state of the application. So the state of the application executed on a server, we knew that the state of the server was count is 0, and this bracket 0 basically is information to the framework to basically restore, using the use lexical scope method, to restore the state of the system, right? So the magical part of Qwik is that we know how to take closures and serialize them. Now this is new because we know how to serialize code in the form of JavaScript, but a function in the form of JavaScript has amnesia. When you call that function, it doesn't know what state it is, right? So if you click a button that says add 1, the function will be like add 1 to what initial value? And so the magical part here is that we can store both the behavior, which is the function, and also the state of the system. And so that's basically how kind of Qwik works. So let's do a more complicated example. So in this particular example, there is multiple components on a page, right? Qwik was just a single component with a button, etc. Let's do something more interesting and see what happens. So here we have a component called reactivity. We create a store which has both count and debounced count. So what is a debounced count? Well, there is a watch that basically says, pay attention to count. If the count changes, I want to know about it. And so when the count changes, go print count changed, and set a timer for 2 seconds, and then copy the count into the debounced count. In other words, the debounced count is always kind of like 2 seconds behind what the count is. Once we have this, we basically have our code. Here is our button that says, if you click on it, go increment the count. And then we have a child component, and in the child component, we pass the store down to the child component, and the child component just prints out, hey, I'm printing the child component. And it also prints out the current count. And then it has a grandchild component, which again, we pass the state down, and the grandchild component prints the grandchild render, and it prints the debounced value. So if I click here, 2 seconds later, the debounced value updates, right? So there's this delay that's happening in here. The second thing is happening here, we no longer have a single component, we have 3 components. So let's just refresh this, and let's clear the screen here. I'm gonna refresh this, and the code executed on a server here, right? And so we see that it says, reactivity renders, count change, child and grandchild. So just kind of for a refresher, we go to reactivity, we execute the function that returns our JSX, right? So it says reactivity renders. Then the framework realizes that the watch has changed, so the console log count changed, updates over here. Oops. And then we go to our child component. Child component says, I am being rendered. And finally, we go to grandchild component. The grandchild component says, I am being rendered, right? So the fact that the server does this pre-rendering, that kind of makes sense. So if you go to the client and we look at the console, obviously, nothing's being printed to the console because we haven't interacted with it yet. And just like in the other cases, if you look at the network tab, nothing is in there. Now, let me click plus. Notice bunch of code downloads. 2 seconds later, more code downloads, right? Because the update happened with a delay. Let's again go to the console. Let me refresh to clear it. Bunch of things changed. 2 seconds later, grandchild updates. The thing that you will not see over here is that the system realized actually the reactive component right here, the stop level component here, the system realized, oh, this is actually static. At no point will this component ever change, and so that function actually doesn't execute, right? We are able to look at the graph of components, and we understand which components change and which don't, and then just don't download the JavaScript for it, and also don't execute that particular component. So we are pruning the tree of all the possible components that actually can execute. Now, let me show you how this actually works. So let's go to an intermediary component called child. And, child is right here. And the child displays the current count. So what we're going to do is we're going to say something like ignore. And so because of how JavaScript works, this ignore basically makes sure that this piece of code never, ever executes, right? So if you refresh the page, you're going to see that it says ignored. And debounce is 0. The code is not here. If I hit plus, the count has changed. 2 seconds later, the grandchild updates. But notice what's no longer there. The child did not re-render. Because the system understands, well, when I change the count, I don't actually need to re-render this particular component, right? So as a developer, you just build your application as you normally would. And the system looks at it, this information, and based on how the components update, we can figure this out. Now, at this point, you might be wondering, like, well, how does this magic actually work? What's happening actually here is that useStore creates a proxy. And that proxy contains getters and setters. And so we can notice when you go and execute props state count. And therefore, we know you're creating a subscription. We know that when the count changes, we have to re-render this component. And by essentially short-circuiting this read, we have prevented the read from happening, and we have prevented the code from updating. And so now we know that the code doesn't have to update. The second thing we do is when the application executes, we serialize all this information inside of the HTML. And because the state of the system is serialized, this is why we talk about Qwik applications being resumable. They run on a server, and when they finish running on the server, we serialize everything we know about them. Location of listeners, the state of the application. We serialize subscriptions, who cares about what. And the subscription is needed because we need to be able to wake up components when things change. And when all this information is serialized, what we can do on the client is we can just continue execution where the server left off, right? So normal applications, they have to download all the code and execute it in order to figure out where the listeners are and then kind of build up internal state of the framework, whereas Qwik doesn't have to do any of that stuff. It can literally just continue where the server left off. And I'll show you a cool demo of that in a bit. But all kinds of new things become possible if you think about it in this particular way. My favorite demo is actually this clock demo. What this shows is, we generate a list over here so that the clock itself is below the fold. And then this just shows the clock. But let me refresh this one more time and look at the network tab. And so the network tab, again, shows no JavaScript present. When I scroll it into the view, it downloads a piece of code to update the clock every 1 second. And it also downloads the JSX, which is the how do you kind of re-render the particular component. And what I find very cool is that if I go and look at the HTML, you can see the HTML updates every 1 second, right? But let me scroll to the top. Let me refresh the page. Notice no updates are happening, right? So the code isn't even present. And then once the component scrolls into the view, bam, we reload the code, we start executing the behavior, and we make the component actually work. And I think that's how frameworks should work. Like, people have been talking about this idea of like, well, this component is off screen. Why are you executing it? You don't have to. It turns out it's actually very, very difficult with traditional frameworks because traditional frameworks can't really reason about the components independently. They always reason about the whole tree of components, and they always render the whole tree of components. They always update the whole tree of components, and they require that the whole tree of components gets downloaded eagerly. And so this kind of thing would be actually extremely difficult to do with your favorite framework. And I actually invite you as a mental exercise to think about it, like, what would you have to do in order to make this happen? And of course, you might be asking yourself, well, great, that's super cool. What does it look like? So let's look at clock. So clock application, we just start with making an array of 40 items. This whole thing is here just so we can create a bunch of stuff so we can push the clock below the fold, right? So this top component really is static component. And the framework knows that it's static component and won't download it to the client. And on the bottom, we just say clock. This is our clock component. And what the clock component says, well, I need you to download some styles. And notice the $, which means the whole thing is lazy. I'm going to have a state. So these are a minute and second. And I'm going to store it as the degrees, the angle of each of these hands. And I'm going to have a use client effect. And use client effect basically has an update function, which will read the current time and update the second, minute, hour. And I will basically execute this function every 1 second. Now, because this is a use client effect, the system knows that this doesn't run on the server. This only has to run on the client. And because it's an effect, we have to kind of eagerly wake it up. And so the question becomes, when should it be woken up? And the default behavior of use client effect is to actually wake it up when the component becomes visible. And so you can pass a second argument here and change the behavior in here, but the default is just do it when it's visible. And so what you get is this beautiful thing where like, hey, the code is not needed, it's not downloaded, I scrolled it into the view, now I'm going to download the code, execute it, etc., to make all the right stuff works. So that's my favorite demo. But let's go further. Every demo has to have a Hacker News, and so the thing I'm kind of demonstrating here is that Hacker News has to go and talk to some fetch API or REST API, right, where it gets back a JSON saying what are all the stories and so on and so forth. And these stories have to be data bound to the components. And so as we're data binding the components, remember we have these proxies and we figure out what is what in terms of subscription. And so you might get to the situation, because we have to serialize the state of the system, we can get in a situation where we actually serialize the whole JSON from the server. But notice what we serialized in here. If you look at the script tag, actually it says nothing. Basically, even though we were talking to the server, even though we got a whole bunch of data, the system was able to recognize the fact is that all of that data is static. You can't actually edit it. There isn't a button present on this page which would allow you to edit this particular data. And this data is only data bound to components that themselves don't re-render. And as a result, the system was like, you know what? This data, I don't need to send it to the server, to the client. And so it gets tree shaken away. So not only is Qwik tree shaking the behavior, it's also tree shaking the data that's coming to the client. And let me show you how this actually works when you go to a comment. So let's open up one of these items. We go to the comment, and one of these things that the comments, well, let me before I go here, let me just show you that the landing page and the internet is slow. Okay, never mind. What I wanted to show you is, oh, okay, now it's working. No. Here's the page. One of the things I wanted to point out is, because there is no kind of behavior on this page, no matter what you do here, at no point will you actually download any sort of JavaScript, right? So again, this is a situation where the framework can just correctly deduce, like, hey, nothing to be done over here, no JavaScript gets downloaded, and so you know, it's a static page. In this particular case, we have this button here, and so clicking on this has to download a bunch of JavaScript to kind of collapse it. And so you can see that now it says 6 replies collapse. If I open it up, it goes back to the previous state and so on and so forth, right? So this actually changes. The first page never changed. There's nothing we could do to change it. The second page actually changes, but if I refresh it, you're going to notice that the only data that got serialized is the state of whether or not this particular component is opened or not. What we didn't serialize is the actual comments. And again, this is Qwik looking at the graph of relationships of which component cares about which data, and you know, what interaction needs what data to update which component, and realizing that there isn't any interaction that the user can do that would possibly cause a component that contains the data binding to wake up. And because that component will never wake up, there is no need to send the data associated with that component. And so it's a tree shaking not just on kind of the behavior level, but also on the data level. All right, and so every framework demo also has to have a to-do application. So this is a to-do application, and I'm sure you've seen this before, and the cool thing to talk about is the network tab. And you know, when I start typing, code has to get download. When I hit enter, more code downloads. And as I interact with the application, I'm continuously downloading more and more code. More and more behavior is coming to the page, right? And again, this is very different from the way normal applications work. Now, I want to point out something unique, which I think kind of demonstrate this. In a normal application, there is really one entry point. There is one way that an application can get bootstrapped, right? You have your, essentially your main method. And then the bundlers kind of make your bundle, and they can't really break the bundle in any other way. Like, once you refer to the root component refers to its children. And those children refer to their children, and those children to their children, and so on and so forth. And those components refer to their closures associated with the listeners, which in turn refer to other things. And so if you have a normal system, there isn't any way by which you can break it up into other things. The only way you can break your bundle up is by you, as a developer, manually introducing a dynamic import. But this is very different from Qwik, because really the only thing you have to do in Qwik is put a single character, the $, right? And the $, internally will move things around so that it creates a dynamic import. And so it's a lot less work. The other problem with dynamic imports is that as a developer, you need to figure out like where to put them. And this is not an easy thing to figure out because, well, the framework you're using is synchronous, whereas dynamic imports is asynchronous, it returns a promise. And so you can't just like randomly place it inside of your code because that just doesn't work because the framework expects synchronous responses. So this breaking things up is hard. And the reason why you need it is because when I start typing here, I download this particular file, which is header component fragment input unkey up. And if I refresh this and I click maybe on this button, I have a completely different file which I'm downloading. The thing to understand is you don't have a single entry point to your system. You have many, many different entry points to the system. How many? Well, it turns out as many entry points as there are listeners that exist on the particular page, right? So one of the trickiest or the hardest or the thing that is the most differentiated about Qwik is the fact that you can write your code as you normally would. And Qwik can take that code and break it up into lots and lots of entry points. And these entry points are important because it's the way how we can say like, oh, I need that button's behavior, but not that button's behavior, right? And normally, breaking this stuff up like that is essentially impossible. Now, here's another demo that I want to show, which I think is very cool. You have your application, and we serialize the state of the application in here. And so when you type a new item like new item, notice the script tag disappeared. Let me show this again. See the script tag? When I start typing, basically when I start interacting with the Qwik application has to figure out kind of the state of the system so that it can resume where the server left over. And that state is serialized inside of that JSON. So we just do JSON.parse, and then we can just continue running from where the server left over. And so we can go and change the application. Now, the cool thing we can do is we can go and grab what we call a container. And so the other thing you have to see is that this container says that it's currently resumed. Let me run it again. It's showing it that the application is currently paused. It's not running. That's why we have our script tag. And when I start interacting with it, notice it changed its state into resumed. So what I can do is I can pause the application again. And so I can do that by qwik.pause. And when I do that, notice it changed back to pause, and it took the script tag and it put it back in there. Basically, it took the state of the application and put it back inside of the HTML. Now, the thing we can do now is we can just copy this HTML. And let's go to a new tab. Completely different page, right? Inspect, and we can grab the HTML over here. We can go edit, and I'm going to delete the HTML that's present, and I'm going to paste the HTML from the other side. Now, pasting HTML, the fact that the application or the page kind of refreshes, that in itself is not surprising. Like, of course it refreshes, I just pasted the HTML. But the question is, will you be able to interact with the application? Now, on any other framework, the answer would be, nope, you can't do that, right? Because the framework has been kind of, the whole state of the thing has been destroyed. But in Qwik, yeah, you can continue to interact with it. You can click on it, check it, and it's continuing where the server left over. And so you might say, well, that's kind of cute. Like, why would you care about this? Well, this capability is actually how we get from the server to the client. We can run the application on the server, and at any point we can pause it, which serializes its state into HTML, ship the HTML anywhere we want, and resume, meaning continue running where you left over. And of course, this trick can be done as many times as you want. And so one useful thing would be, for example, imagine you have something like VS Code. VS Code is actually just a JavaScript application, right? Wouldn't it be nice if when you close the VS Code would just like pause it, serialize the HTML that exists in the system, and when you come back, it would just put the HTML back in and resume where you left off, right? So if you have PWA application, this might be a nice way of saying, oh, the application is getting closed. I'm just going to take the HTML, put it inside of IndexedDB, and then I can resume it and continue running from where I've left over. So I think this is a kind of a pretty cool demo, and I think it really demonstrates what we mean when we say resumability. And it is clearly something completely different from hydration, which is what other frameworks do. Nope, let me go back here. Okay, we talked about to-do. So I wanted to talk about a little bit about how existing frameworks work, because I think it really kind of paints the difference in the terms of pictures. So existing frameworks are what I call monoliths. What I mean by that is that you server-side render the page, and that's shown here as gray boxes, right? Your HTML is sent to the client, and the user sees the application, but they can't interact with it because there's no listeners attached to anywhere. And so hydration is really this super expensive process by which the framework reruns the application in order to figure out where the listeners are, right? So what that means is the server sends HTML. The next thing browser has to do is to download the JavaScript. And once it downloads the JavaScript, it can go and reconcile the JavaScript against the HTML. And that's what turns the components blue. We say they're hydrated. Now, at this point, I want to point out something important, which is people might say like, oh, I'm going to be smart, and I'm going to lazy load the component, and that's how I'm going to break my large application into small applications. Well, guess what? If that component is currently on the rendered page, it doesn't matter. You have to go grab its JavaScript code, and you have to hydrate itself as well. In other words, current frameworks can only lazy load components that are not currently visible in the page. If the component is visible, it has to be downloaded and eagerly executed so that the hydration code can execute and recover the listeners for this particular component. So this is kind of how standard applications work. And there's a new kid on the block called Astro. And what Astro says is like, you know what? How about we take this big application, which is expensive to hydrate, and we turn it into smaller applications. So if I click on just this portion of the page, then only this portion of the page hydrates. And so this is known as islands inside of Astro, and it greatly improves the situation because instead of hydrating this huge app, you now have smaller chunks to hydrate, and that's better. But it creates a new problem, which is that frameworks, one of the things that frameworks do is they solve the inter-component communication problem, right? Like how do components talk to each other? How do they pass data? How do they wake each other up? How do I know that this thing has to be re-rendered? And with Astro, that particular problem is not solved because if this particular component said that I actually have to update this guy over here, that's up to you. Astro doesn't solve that for you. So the whole inter-application communication becomes unsolved. And so now we come to Qwik. And Qwik is unique in the sense that if I interact with a particular component, just that component gets awoken. And it doesn't even make sense to talk about hydration because like there is no listeners that are being attached. The listeners are already there in the form of attributes inside of HTML. So waking a component up really just means deserializing its state, and that's just JSON parse, which is unbelievably cheap. Yeah, compared to downloading and executing JavaScript, JSON.parse is a freebie. It doesn't even cost anything. And so the other thing I want to point out is that when I interacted with a component, it didn't force me to wake up the parent components or the child components. And this is important because if you have a component, typically component has props, right? Typically component has things that the parent component has given it. And so you can't just go to React or Angular or somebody and say, like, go render this component in isolation because the component has a bunch of properties that got passed from the parent. And the same thing happens with the children. There is no easy way to go to the framework and say, A, don't render the children, but B, more importantly, don't even download the children. Because when a parent component refers to a child component, it refers to it as an import. And therefore, the moment you load a particular component, you're automatically loading all of its children to go with it, right? So the thing to figure out is not just how to isolate it from the point of view of execution, but you also have to figure out how to isolate it from the point of view of lazy loading of the bundlers. And so, of course, Qwik has reactivity. So if I interact with this component over here, not only is this component woken up, it also understands that I have changed data that causes this other component to also be downloaded and re-rendered, right? And so Qwik is very surgical about what kind of code it downloads and when it downloads it. Now, I've been talking about a bunch of these applications, and I wanted to show you that actually these are not separate applications that I've been working with. This actually is one big application that I have put together. So here is all of these components we've been talking about. Here's our hello world, which is static. Here's our simple counter, React counter. Here's our to-do app. Here's our clock. All of these components are actually part of a single application. And notice the same property actually just happens. So if I am here, I look at the network tab. Nothing is in the network tab until I scroll to the clock. The clock got woken up. I start clicking on the click button. That's when the code for the click button shows up. I can click on the debounce thing. And with a 2-second delay, more code shows up. And here's our to-do app, and I can add stuff to it. And again, as I interact with it, more and more code is showing up to the system. So the whole thing works on basically any page you have. And the thing that we're going after is to just be able to lazy load the whole thing. Now, at this point, you might say, like, yeah, but like I go to a web page, and then, of course, what happens when there is, the internet goes down, or when I click the first button, isn't it annoying and a slow system that it would have to take forever to download? Well, I was showing you demos, and because it's a demo, we disabled the prefetching. But in the real system, what actually happens when we render the code, we know which components exist where, and we know where the listeners are, and we know all the possible things you can do as a developer. And so we automatically inject a bunch of prefetch links to your system so that the application downloads. Now, at this point, you might say, like, well, I'm just downloading an application. Isn't this any different from downloading a regular application? And the answer is no, for two reasons. Even if you download all the JavaScript code that you would download in a normal application, you've actually saved yourself the cost of executing the code, right? So the first benefit you have is that even if you download all the same amount of code, you don't have to execute it. So right there, huge savings. But the code that's here is already tree shaken, right? This code has already gone through the system, and the framework realized there's a whole bunch of static components that will never ever re-render on the client, and therefore there's no need to ship their code to the client. And so what you see over here is a pruned list of things that are actually interactive on a page, right? So you have two savings. One is less code is getting shipped, and the code is actually not executing, but it gets better. Because we have this list, and because we know how people actually interact with the application, we can keep statistical information as to what is the most likely thing that you as a user will click on the website. And as a result, we can prioritize this list. We can send this list in the order of what we think is most likely thing that the user clicks on. So even if you're on a super slow site, but you think you're going to click the buy button, we can send you the code for the buy button first, and only later we send you the code for the logout, because nobody ever clicks at the logout button, right? But we can do these kinds of tricks. And again, these are the kind of tricks that are really not possible with existing frameworks. I'm going to pause here. And I'm going to invite you to ask questions. And I assume there's a mic that goes around. Nobody. Yes. The nice gentleman that was borrowing the dongle for me.
Hey there.
Hi.
So my question is, since, we are prefetching the JavaScript and whatsoever, but we are not executing it, how does it guarantee that we are not, for instance, replacing the downloaded JavaScript with some malicious stuff?
Oh, so all of these things that you can see over here are generated by Qwik. So remember, most frameworks care about how do I render? And that's where their interest ends. And what makes Qwik unique, and the reason why Qwik can do all of this crazy magic, is because Qwik doesn't just care about execution on a client, it also cares about execution on a server, and it also cares about bundling, it also cares about how do I break the code up into pieces. All of these things are the domain of the framework, right? And as a result, what you see over here are very specific URLs with hashes incorporated in them that the Qwik controls. So it's not like you can just modify these particular things. Qwik won't allow you to do that.
Okay, thank you so much.
So if you have a question, please raise your hand.
Anything online?
No.
Well, I hope you enjoyed it. I will be probably hanging out over here somewhere, or probably in front of the door. So if you have further questions, please stop by, ask them. And I love chatting about this and demonstrating the differences. Hope you enjoyed it.